Well, good morning, ladies and gentlemen. On the screen is a list of the main topics I'll be going into today, although I have to confess up front I may have to stop before we can finish the global warming and the free market, just for lack of time. Well, the theme of environmentalism is that continuing economic progress is both impossible and dangerous. It is allegedly impossible because of the impending exhaustion of natural resources. It is also allegedly dangerous to the extent that it is possible because of harm to the environment. In opposition to the theme of environmentalism, I'm going to begin by explaining what I consider to be two fundamental propositions concerning our subject, environmental and resource economics. First, for all practical purposes, there is no limit to the potential supply of natural resources. The same process by which man increases the supply of manufactured or processed goods, namely growing scientific and technological knowledge embodied in more and better capital goods, enables him also repeatedly, indeed regularly, to increase the supply of economically usable, accessible natural resources. Second, by their very nature, production and economic activity improve man's environment, not harm it, as the environmentalists claim. To understand why, for all practical purposes, there is no limit to the potential supply of natural resources, we must distinguish between two senses of the expression natural resources. First, there are natural resources provided by nature, as provided by nature. And second, there are natural resources originally provided by nature to which man's productive activity has given the character of goods and wealth. I term these latter economically usable, accessible natural resources. This distinction is rarely made. Typically, it is assumed simply that natural resources come straight from nature, and that man's only connection with them is to use them up, without being able to replace them. Thus, man allegedly produces merely products, such as automobiles and refrigerators, and in the process consumes irreplaceable supplies of nature-given goods, such as iron ore and petroleum. This, of course, is what the environmentalists and conservationists believe. It is on the basis of this belief that they urge us to, quote, reduce, reuse, recycle, and are convinced that whatever depends on mining operations of any kind cannot be sustained, for sooner or later the mines will give out. However, once we think in terms of the two senses of the expression natural resources, it becomes clear that the conventional view both radically overstates the contribution of nature to natural resources and also radically understates it, each, of course, in a different respect. The overstatement of nature's contribution consists of ignoring man's contribution to natural resources. For example, nature provides the chemical element iron, and it provides the chemical compound petroleum. However, it does not provide iron mines or oil wells, or even iron or petroleum in the form of goods. Before there can be such things as iron mines or oil wells, an enormous human contribution is required. First, man must discover uses for iron or petroleum that nature has provided. Only after such time is it possible for iron or petroleum to acquire the status of goods or wealth. For the thousands of generations of human beings who lived and died before the end of the Stone Age, and even for many generations thereafter, iron was not a good. It was not a good because, not knowing its uses, people were not in a position to derive any actual good from it. The same is true of petroleum. It did not become a good until sometime around the middle of the 19th century, when it was discovered that petroleum could be used to make kerosene, which in turn could be used as fuel in lanterns. Only then were people in a position to derive any actual good from petroleum, and only then did petroleum become a good. Every natural resource that is a good, unless its benefit comes to us automatically, like that of atmospheric air and sunlight, without our having to perform labor or take conscious action of any kind in order to obtain its benefit. Apart from these cases, every good, its being a good, rests on a human contribution, no less than on nature's contribution. What nature provides is mere things. And we must recognize with Karl Menger, the founder of the Austrian school, that, quote, if a thing is to become a good, or in other words, if it is to acquire good's character, all four of the following prerequisites must be simultaneously present. 1, a human need. 2, such properties as render the thing capable of being brought into a causal relationship with the satisfaction of this need. 3, this is particularly important, human knowledge of this causal connection. And 4, also especially important, command of the thing sufficient to direct it to the satisfaction of the need. End quote. The quotation from Menger implies that besides the discovery of uses for it, there is a second requirement of a thing becoming a good that rests on man's contribution, and that is his final prerequisite, namely command of the thing sufficient to direct it to the satisfaction of the need. What this refers to is the fact that in order for any particular deposit of iron or petroleum or anything else to qualify as a good or wealth, not only must it specifically be discovered, but also man must establish a power of physical command over that specific deposit sufficient for him to be able to get to the deposit, extract it, and then put its contents into a form and bring it to the locations where he is actually able to put it to its intended uses. However useful we now know it to be, the mere chemical element iron is not a good, at least not yet, insofar as it is located on Mars, or is found in the Earth's core, or under the middle of the ocean, or in some other presently inaccessible place. In fact, it would not be a good any time soon, even after we establish the physical ability to send a rocket ship to Mars and have it return with some Martian iron ore. For an implication of Menger's view is that we must have command over the thing sufficient to enable us to use it gainfully. Sending perhaps a $100 billion rocket ship to fetch a few dollars worth of iron ore would not be a gainful process. Thus, taken in its context, iron on Mars would still not be a good, because getting it could not actually do us good. Exactly this point applies at present to deposits of shale oil. Shale deposits are not yet goods or wealth, even though we know that they contain oil and know what can be done with the oil and have the technology to extract oil from shale. The problem is the cost. However, if and when sufficiently more efficient methods of production were developed to make possible the gainful extraction of oil from shale, such deposits would thereupon achieve the status of economic goods and wealth, for they would then be able to do us actual good. The supply of economically usable, accessible petroleum, of course, would be dramatically increased. These points have major application looking back at recent economic history. The supply of economically usable, accessible iron ore has been dramatically increased over the last 2 centuries as man has increased his ability to dig deeper in more locations and to do so with less and less human labor and at lower and lower real cost. It has increased as man has improved his knowledge of nature and learned to break down different compounds more economically, such as becoming able to separate iron from sulfide compounds as well as oxide compounds, and to do so more economically. Similarly, the supply of economically usable, accessible petroleum has steadily increased as man has developed knowledge and produced the capital equipment that enable him to drill efficiently at greater and greater depths in more and more locations, and to work deposits previously impossible or too costly to work. One of the major accomplishments of Rockefeller and Standard Oil, for example, was to develop the process of petroleum cracking. This enabled oil deposits containing a high sulfur content to become workable and correspondingly increase the supply of usable, accessible petroleum. Well, so much for the overstatement of nature's contribution to natural resources and the corresponding understatement of man's contribution. Now let me turn to the respect in which nature's contribution to natural resources is itself understated. Nature, of course, does contribute the material stuff that is in all the mines and wells. It contributes all the chemical elements and compounds. However, its contribution of chemical elements and compounds is hardly limited to the quantities that reside in what man has thus far been able to make into goods in the form of mines and wells and the like. Nature's actual contribution of natural resources is immensely greater than this. In fact, it comprises the totality of matter and energy in every form, known and or as yet unknown, that exists in the earth and indeed, to be strictly accurate, in the entire universe. As I said on a previous occasion, even if we limit our horizon exclusively to the planet Earth, which certainly need not be our ultimate limit, the magnitude of natural resources supplied by nature is mind-bogglingly huge. It is nothing less than the entire mass of the Earth and all of the energy that goes with it, from thunderstorms in the atmosphere, a single one of which discharges more energy than all of mankind produces in an entire year, to the tremendous heat found at the Earth's core in millions of cubic miles of molten iron and nickel. Yes, the natural resources provided by nature in the Earth alone extend from the upper limits of the Earth's atmosphere 4,000 miles straight down to its center. This enormity consists of solidly packed chemical elements. There is not 1 cubic centimeter of the Earth, either on its surface or anywhere below its surface, that is not some chemical element or other, or some combination of chemical elements. This is nature's contribution to the natural resources contained in this planet. It indicates the incredibly enormous extent of what is out there awaiting transformation by man into natural resources possessing goods character. A little elaboration may be helpful. As I've written, the Earth's core is composed mainly of iron and nickel. Millions, probably billions of cubic miles of iron and nickel. The oceans and atmosphere are composed of millions of cubic miles of oxygen, hydrogen, nitrogen, and carbon, and of lesser but still enormous quantities of practically every other element. Even the sands of the Sahara Desert are composed of nothing but various compounds of silicon, carbon, oxygen, hydrogen, aluminum, iron, and so on, all of them having who knows what potential uses that science may someday unlock. Nor is there a single element that does not exist in the Earth in millions of times larger quantities than has ever been mined. Aluminum is found in some quantity practically everywhere. There are immense quantities even of the very rarest elements, such as gold and platinum, to be found floating in trace amounts throughout the oceans, for example. The key to understanding the subject of natural resources is to realize that at any given time, the supply of economically usable, accessible natural resources is never more than a very tiny fraction of the supply of natural resources supplied by nature, and that the fraction is capable of progressive enlargement for an indefinitely long period of time, while all the while remaining infinitesimally small in comparison to what is out there in nature. The fraction is enlarged on the same basis as man's ability to produce goods in general is enlarged, namely scientific and technological progress and saving and capital accumulation. These provide growing knowledge of and physical power over nature and thereby enable man to convert a larger and larger portion of nature into economically usable, accessible natural resources. To judge how early we still are in this process, it should be realized that despite all of the progress of the last 2 centuries or more, all of our mining efforts are still confined almost entirely within the 30% or so of the Earth's surface that is land, and in depth are still measured in feet rather than in miles. The technology and the capital equipment that will break through these barriers are already on the horizon, and provided that their development is not thwarted by environmentalism or by government intervention otherwise inspired, clearly have the potential to enlarge the supply of economically usable, accessible natural resources in the centuries to come, far beyond anything we have been able to achieve up to now. Advances in fiber optics and robotics have the potential to open up to mining operations the 70% of the Earth's surface that is beneath the oceans. Those and related advances that would make it possible to mine on land at depths of several miles instead of the presently much more limited depths would also expand the fraction of the Earth's mass accessible to and usable by man far beyond anything that has existed up to now, with a corresponding enlargement in the supply of minerals of all kinds. I think it is important to realize just how modest present-day mining operations are in comparison to the size of the Earth. I've gathered some important empirical data on the subject. For example, total global production of petroleum is approximately 30 billion barrels per year. Each barrel of petroleum measures approximately 0.16 of a cubic meter. This means that in terms of cubic meters, the physical volume of all the petroleum extracted in the world in a year is 0.16 times 30 billion, which is 4.8 billion cubic meters. Since 1,000 meters equals 1 kilometer, a billion cubic meters translates into a mere 1 cubic kilometer. So the physical volume of total annual global petroleum production is presently 4.8 cubic kilometers. And because 1 cubic kilometer equals approximately 4.17, because 1 cubic mile equals approximately 4.17 cubic kilometers, this means that all of the world's petroleum production in a year represents about 1.15 cubic miles. All by itself, this is enough to suggest that total global mining operations are extremely small relative to the size of the Earth, which is 1.1 trillion cubic kilometers, or approximately 260 billion cubic miles. This conclusion is confirmed when one considers the global annual production of other important minerals, such as iron ore, coal, aluminum, and natural gas. Global iron ore production was approximately 1.16 billion metric tons in 2003, the most recent year for which I have data. The density of iron ore varies between approximately 4 metric tons per cubic meter and 5 metric tons per cubic meter, depending on the type of the ore. Using the lower figure of 4 metric tons per cubic meter and dividing it into the total of 1.16 billion metric tons of ore produced, the total cubic volume of iron ore production in 2003 would be 290 million cubic meters, which is 0.29 cubic kilometers, or 0.07 cubic miles. Because much of the ore extracted has a higher density, the actual physical volume of iron ore extracted was considerably less than 0.07 cubic miles. Global coal production in 2004 was 2.73 billion metric tons. Since the density of coal is roughly 1.3 metric tons per cubic meter, the physical volume of the coal extracted was about 2.1 cubic kilometers, or about 0.5 of a cubic mile. The situation is similar in the case of aluminum and natural gas. If we add up all of the cubic volumes, they total 11.96 cubic kilometers, or 2.87 cubic miles. To allow both for the mining of everything else and for any extractions we may have overlooked in connection with the items we've considered, let's just assume the nice round number, greatly larger than what we've indicated, the nice round number of 100 cubic kilometers, or roughly 24 cubic miles, as representing all the current mining operations combined on an annual basis for the world as a whole. In a tolerably free, rational society, motivated human intelligence is easily capable not only of continuing man's ability to extract the volume of useful materials from the earth, but also to substantially increase it. If the present annual volume of such extractions were merely to continue, it could do so for at least the next 100 million years. By that time, a total of 10 billion cubic kilometers, or roughly 2.4 billion cubic miles of earth would have been extracted, which would represent a little less than 1% of the Earth's total physical volume. If economic progress in coming centuries serves to increase the annual rate of extractions by a factor of 100, then mining operations could continue on that vastly larger scale for 1 million years before 1% of the Earth's volume had been extracted. The exhaustion of usable, accessible natural mineral deposits is simply not a problem for an economy as free as that of the United States was until just about 2 generations ago. I turn now to the second proposition, namely that by their very nature, production and economic activity improve man's environment. This proposition follows from the fact that physically the world consists of nothing but solidly packed chemical elements, and that from the perspective of physics and chemistry, all of production and economic activity consist merely of changing the combinations and locations of the various chemical elements. The production of automobiles or refrigerators, for example, entails the movement of some part of the world's supply of the element iron from such locations as the Mesabi Range in Minnesota to places all across the country and the world. In the process, the iron is broken out of combination with certain other chemical elements, such as oxygen or sulfur, and put into combination with different chemical elements, such as chrome or nickel. The overall quantity of each of the elements in the world remains exactly the same as before. The only difference is the relationship of the chemical elements to human life and well-being, which is obviously vastly improved by man's productive activity. Iron buried in the hillsides of Minnesota is useless, but changed by human productive activity to take the form of automobiles, refrigerators, bridges, and skyscrapers, and countless other products, it is of immense utility. Similarly, man's productive activity moves some part of the world's uranium and the elements constituting the world's coal, oil, and natural gas from the locations in which nature has placed them, and with some changes in composition, relocates them in power plants and fuel tanks, thereby enabling them to release energy to heat and light homes, power industrial machinery, automobiles, airplanes, ships, and railroad trains, and in countless other ways serve human life. These examples capture the essential nature of productive activity, its fundamental purpose and regular consequence is nothing other than the improving of the relationship of the nature-given chemical elements to human life and well-being. That's the inherent nature of production and economic activity, to improve the relationship between the various chemical elements and compounds that nature provides and human life and well-being. When one stops to consider that man's physical environment consists of nothing but chemical elements and their actions, and that productive activity serves by its nature to improve the relationship of those elements to human life and well-being, it follows that productive activity, by its nature, serves to improve man's environment. And that fact, indeed, is present in the common recognition that the central concern of economic activity is precisely with the improvement in the external material conditions of human life. which again is nothing other than man's environment. If you're concerned with the improvement of your external material conditions, those external material conditions are all the various chemical elements and their actions that exist in nature, and that's what our economic activity improves. Economic and productive activity improve man's environment in every respect. As I've written, to live, man needs to be able to move his person and his goods from place to place. If an untamed forest stands in the way, such movement is difficult or impossible. It represents an improvement in his environment, therefore, when man moves the chemical elements that constitute some of the trees of the forest somewhere else and lays down the chemical elements brought from somewhere else to constitute a road. It is an improvement in his environment when man builds bridges, digs canals, opens mines, clears land, constructs factories and houses, or does anything else that represents an improvement in the external material conditions of his life. All of these things represent an improvement in man's material surroundings, his environment. All of them represent the rearrangement of nature's elements in a way that makes them stand in a more useful relationship to human life and well-being. Man improves his environment by adapting it to himself. The environmentalists, of course, do not see things this way. In their view, production and economic activity represent systematic harm to the environment. That is because, to them, the environment is not the surroundings of man deriving its value from its relationship to man, but nature in and of itself, deriving its value from itself, i.e., allegedly possessing intrinsic value. To see this point clearly, consider the following example. 30 years ago, the land under the house I live in Southern California, was empty desert. Had I wanted to sleep in the same location that my bedroom now stands on, I would have had to bring a sleeping bag, take precautions against rattlesnakes, scorpions, and coyotes, and hope I could find a place for my sleeping bag such that I wouldn't have rocks pressing into my body. If it rained, I would get wet. If it was cold, I would be cold. If it was hot, I would be hot. Going to the bathroom would be a chore. Washing up would be difficult or impossible. How incomparably better is the environment provided by my house and my bedroom. I sleep on a bed with an innerspring mattress. I don't have to worry about snakes, scorpions, or coyotes. I'm protected from the rain, the cold, and the heat by a well-constructed house with central heating and air conditioning. I have running water, hot and cold, a flush toilet, a sink, a shower, and a bathtub. In fact, more than one of all of these things. And I have electricity and most of the conveniences it makes possible, such as a television set, VCR, and CD and DVD players. It's obvious to me that the existence of my house constitutes an enormous improvement in my environment compared with living at the same location on the bare ground, and that the same is true of the existence of virtually all houses in relation to the environment of their occupants. It's further obvious to me that the process of improving the environment in this way starts with developers and contractors who bring in bulldozers and other heavy construction equipment to clear the tops of hills, level and compact the land, build streets and utility connections, and construct houses. The environmentalists, of course, describe the exact same process of development and construction as harming the environment. Why? Because in their view, hillsides and empty land, as it exists in a state of nature, together with its wildlife, have intrinsic value. And those alleged intrinsic values are allegedly harmed by development and construction. In other words, the harm the environmentalists complain about in such cases is harm only from a non-human, indeed anti-human perspective. And here is one of the very clearest statements of the doctrine of intrinsic value to be found anywhere, along with some leading implications. This, man's remaking of the earth by degrees, makes what is happening no less tragic for those of us who value wildness for its own sake, not for what value it confers upon mankind. I, for one, cannot wish upon either my children or the rest of Earth's biota, his brother worm, I guess, a tame planet, be it monstrous or, however unlikely, benign. McKibben is a biocentrist, and so am I. We are not interested in the utility of a particular species or free-flowing river or ecosystem to mankind. They have intrinsic value, more value, to me, than another human body or a billion of them. Human happiness, and certainly human fecundity, are not as important as a wild and healthy planet. I know social scientists who remind me that people are part of nature, but it isn't true. Somewhere along the line, at about 1 billion years ago, maybe half that, we quit the contract and became a cancer. We have become a plague upon ourselves and upon the earth. He goes on, it is cosmically unlikely that the developed world will choose to end its orgy of fossil energy consumption and the third world its suicidal consumption of landscape. Until such time as Homo sapiens should decide to rejoin nature, some of us can only hope for the right virus to come along. End quote. This quotation appeared back in 1989 in a prominently featured Los Angeles Times book review of McKibben's The End of Nature. Now, the doctrine of intrinsic value and its anti-human perspective permeates environmentalism. It is especially prominent in the continuous denunciations of mankind for destroying various species of animals and plants. The truth is that man's actions with respect to the various animal and plant species have radically improved his environment. He's enormously increased the populations of those species that are of benefit to him, such as cattle, sheep, chickens, pigs, horses, and cats and dogs. These species benefit him variously as food, as means of transportation, and as pets. At the same time, he's greatly improved all of these species through scientific breeding. Obvious examples are Holstein cattle and Persian cats and toy poodles. At the same time, man has radically reduced the populations of species that are harmful to him, such as wild beasts, rats, lice, and other vermin. In the vegetable kingdom, he's radically enlarged such plant species as wheat, rye, barley, corn, and all of the various fruits and vegetables he consumes, as well as the flowers he enjoys. As in the animal kingdom, he's greatly improved the various species and created varieties that would not otherwise exist. American beauty roses, for example, do not exist in nature. To make way for the greater presence of the forms of plant life that benefit him, man exterminates weeds. Sometimes an animal or plant species that are neither particularly beneficial nor particularly harmful may be in danger of being eliminated. This can happen where the members of the species are of too little value to make it worthwhile to anyone to preserve them, or those who might find it worthwhile to preserve them are prevented from doing so. Buffalo, whales, alligators, and elephants are or have been in this category. In these particular cases, there would probably be no danger of extinction if private ownership of such animals could be established. In that case, it would probably pay to preserve sufficient numbers to supply markets for their products. For example, elephant tusks for ivory and alligator hides for leather. However, even if these species were lost, it would be a relatively insignificant matter in comparison with the overwhelming good that has been achieved by the increase and improvement of the animal and vegetable species I named earlier. Essentially, what man has accomplished with respect both to animals and plants is not the destruction of species, but the enormous increase in the members of those species that benefit him and the enormous decrease in those species that harm him. In other words, he has succeeded in greatly changing the balance of nature in his favor. This is a leading aspect of his improvement of his environment. Just as it is a better environment to live in a modern house rather than to live on the bare ground, so too it is a better environment to live in a land filled with farms devoted to raising abundant supplies of crops and domestic animals than to live in jungles filled with mosquitoes, poisonous snakes, and wild beasts. I meant to say rainforests. Going further, in rebutting environmentalism, production and economic activity also improve man's environment with respect to the quality of the water he drinks and the air he breathes. Clean water is to be found precisely in the advanced industrial economies of the world, not in the pre-industrial third world countries. This is because it takes the ability to produce such things as large quantities of low-cost pipe and chemical treatment facilities in order to bring clean water to large numbers of people. The third world countries lack this productive ability. Everyone in the United States who lives near the Mexican border can easily confirm this, simply by asking himself where he would prefer to drink the tap water and why. Similarly, one can ask whether it is preferable to drink the tap water in Europe or in Africa, in Japan or in India. The advances in production and economic activity represented by industrialization have improved air quality no less than water quality. The replacement of the horse by the automobile made it possible to avoid the stench and health hazards formerly created every day in towns and cities by large numbers of horses urinating and defecating in the streets. The emissions of automobiles at their worst is a great improvement over the emissions of horses. Modern central heating, air conditioning, and ventilation systems represent enormous improvements in indoor air quality. So too do modern stoves powered by electricity or natural gas instead of wood. They make it possible to avoid chronic eye irritations that often result in blindness, a phenomenon that is a commonplace in third world countries. Industrialization is also what has made possible modern sewage systems and an end to the use of city streets as sewers. Thus, in every respect, production and economic activity are the source of enormous improvement in man's environment. Environmentalism claims the opposite only because its standard of value is not man and his well-being, but the alleged intrinsic value of nature in and of itself, undisturbed by man. By that standard, all the changes in nature that are necessary to benefit man, and thus in fact improve his environment, are regarded as harm to the environment. I want to discuss the nature of environmentalism and its goals. Environmentalism's starting point is the doctrine of intrinsic value, the intrinsic value of nature, which, as I've said, is the doctrine that nature is valuable in and of itself. In the Western world, this doctrine goes back as far as St. Francis of Assisi, who believed in the equality of all living creatures, man, cattle, birds, fish, and reptiles. The premise of nature's intrinsic value does not stop with the animal kingdom or even the animal and vegetable kingdoms. It extends to to an alleged intrinsic value of forests, rivers, canyons, and hillsides, to everything and anything that is not man. As I wrote in Capitalism, the idea of nature's intrinsic value inexorably implies a desire to destroy man and his works, because it implies a perception of man as the systematic destroyer of the good, and thus as the systematic doer of evil. Just as man perceives coyotes, wolves, and rattlesnakes as evil because they regularly destroy the cattle and sheep he values as sources of food and clothing, so on the premise of nature's intrinsic value, the environmentalists view man as evil, because in the pursuit of his well-being, man systematically destroys the wildlife jungles and rock formations that the environmentalists hold to be intrinsically valuable. Indeed, from the perspective of the alleged intrinsic values of nature, the degree of man's alleged destructiveness and evil is directly in proportion to his loyalty to his essential nature. Man is the rational being. It is his application of his reason in the form of science, technology, and an industrial civilization that enables him to act on nature on the enormous scale on which he now does. Thus, it is his possession and use of reason manifested in his technology and industry for which he is hated. Indeed, the doctrine of intrinsic value implies that man is to regard himself as profaning the sacredness of nature by virtue of his very existence. Because with every breath he draws and every step he takes, he cannot help but disturb something or other of alleged intrinsic value. Thus, if man is not to extinguish his existence altogether, he is obliged by the doctrine of intrinsic value to minimize his existence by minimizing his impact on the rest of the world, and to feel guilty for every action he takes in support of his existence. It is on this basis that the environmental movement now urges mankind to destroy industrial civilization by means of radically reducing global emissions of carbon dioxide. In 1990, the UN's Intergovernmental Panel on Climate Change called for an immediate 60% global reduction in carbon dioxide emissions. Last year, Britain's Stern Review called for a reduction of 25% by the year 2050 and an ultimate reduction of more than 80%. Sir Nicholas Stern and the rest of the environmental movement pretend that the loss of fossil fuels will somehow be made good by the increased use of wind and solar power and by technologies as yet undiscovered. Of course, while expanded production of atomic power might be capable of becoming a significant replacement for fossil fuels, the bulk of the environmental movement is even more opposed to atomic power than it is to the use of fossil fuels, for it regards atomic power as the death ray. Indeed, the environmental movement has increasingly come to oppose even the construction of dams to make possible the generation of hydroelectric power. This is because the dams allegedly interfere with the migration of fish, and therefore should not only not be built, but should be destroyed where they have been built. The Stern Review nevertheless claims that the cost of making up for the loss of fossil fuels will amount to a mere 1% of annual GDP per year. One may wonder if this estimate is arrived at on the basis of an assumption akin to a highly efficient prayer machine being developed that will be capable of arranging miracles on demand, such as sunlight being available at night or wind always being present. It's not absolutely impossible that wind and solar power might someday become major sources of power. One of the things that would be necessary would be the ability to store large amounts of power at a low cost, either by means of the use of storage batteries or in some other way. That would go a long way toward solving the problem of wind and sunlight not always being present. Of course, if wind and solar power ever did become commercially viable on a large scale, it would be necessary for the environmentalists not to turn to attacking them because of such things as the problems of disposing of large quantities of disused storage batteries and of birds being killed by rapidly rotating windmill blades or being blinded by the reflection of sunlight from solar panels. It would also be necessary for the environmentalists to be willing to tolerate views of the countryside being spoiled by large numbers of windmills and vast expanses of solar panels. If and when wind and solar power ever become commercially viable on a large scale, they will not require government help in any form in order to succeed. They will make their way in free competition. But if that day were ever to come, I'm confident that the intrinsic value doctrine would lead the environmental movement to attack them in the same way that it attacks all other large-scale human impacts on the environment and the means required for those impacts occurring. The logic of the intrinsic value doctrine makes the environmental movement fundamentally opposed to large-scale energy production in any form whatever. Wind and solar power no less than fossil fuels and atomic power, if their day should ever come. Its goal is to throttle energy production as such, not just this or that particular kind of energy production. This is because the availability of energy on a large scale in any form is what makes possible impacts on nature on a large scale, and thus the destruction of the alleged intrinsic values of nature on a large scale. Today, environmentalism's opposition to fossil fuels is closely tied to fears of global warming, which it is claimed is caused by the carbon dioxide emissions resulting from the burning of fossil fuels. Yet environmentalism was opposed to fossil fuels well before it embraced the doctrine of global warming. It opposed them back in the 1960s, a period in which global cooling was considered more likely than global warming. Its opposition to atomic power and hydroelectricity, of course, also has nothing to do with fears of global warming. The actual issue is energy production as such. The goal of environmentalism is to throttle energy production. Thus, as I say, if and when wind or solar power became commercially viable sources of energy on a large scale, the environmental movement would almost certainly turn to denouncing them along with fossil fuels, atomic power, and hydroelectric power. Thus, the situation is that wind and solar power are very unlikely to become major sources of energy production in the first place, at least in the foreseeable future, and that if they somehow did manage to become capable of being major sources of energy production, they would themselves be denounced and their development largely prevented. This means that we can take the environmental movement's demands for reductions in carbon dioxide emissions as tantamount to demands for reductions in energy production as such. Now, it's important to understand the extent of the reductions in energy production implied by the demands for reductions in carbon dioxide emissions made in the Stern Review and by the United Nations Intergovernmental Panel. Let me start with a 25% reduction in global carbon dioxide emissions urged by the Stern Review by the year 2050. Its application across the world would imply a 25% reduction in carbon dioxide emissions here in the United States by that year. Yet the population of the United States by 2050 is expected to approximate 400 million people. Since the U.S. population is currently around 300 million people, this means that 4/3 of the present population of the U.S. would be expected to generate only 3/4 of present carbon dioxide emissions. Well, 3/4 divided by 4/3 is 9/16, or 56.25%. That would be the projected per capita level of carbon dioxide emissions in the United States in 2050, a reduction of 43.75% from today's level. If the reduction in global carbon dioxide emissions is to be 60% rather than 25%, with the same increase in population, the reduction in per capita emissions in the U.S. would be to a level found by dividing 40%, the emissions remaining after the 60% reduction, by 4/3. Since division by 4/3 is always multiplication by 3/4, the per capita reduction would be to a level of 30% of today's emissions instead of 56.25%. The per capita reduction in emissions in the U.S. would be 70% rather than 43.75%. But there is yet a further major reduction in U.S. per capita carbon dioxide emissions to contend with. And that is that while global emissions will be reduced by 25% or 60%, emissions in China, India, and the rest of the so-called third world will be allowed to go on increasing, presumably until there is equality in per capita emissions across the world. At present, even though it has only 5% of the world's population, the U.S. consumes 25% of the world's energy and is responsible for approximately 25% of the world's carbon dioxide emissions. Assuming the U.S. population to remain 5% of the world's population, the achievement of global equality per capita in carbon dioxide emissions would require a reduction in U.S. energy consumption from its present 25% to 5%, corresponding to the size of its population. But this implies a further reduction of 80% in per capita emissions in the U.S. This is because 5% divided by 25% that we presently have is only 20%. A fall from where we are to 20% of where we are is a fall of 80%. Well, this further decline of 80% in per capita carbon dioxide emissions would apply to the already very substantial percentage declines calculated earlier. Thus, with a rollback of 25% in global emissions, the decline in the U.S. would be to 20% of 56.25%. That's 11.25%. This, of course, would be an 88.75% reduction in per capita U.S. Carbon dioxide emissions. With a rollback of 60% in global emissions, the decline in the U.S. would be to 20% of 30%, i.e. to 6%. This would be a 94% reduction in per capita U.S. carbon dioxide emissions. Now, lest anyone here think that no one is actually advocating the kind of extreme reduction in CO2 emissions and energy production for the U.S. that I've just described, he should be sure to read Al Gore's July 1st New York Times op-ed piece called Moving Beyond Kyoto. There, Gore says, quote, "We should demand that the United States join an international treaty within the next 2 years that cuts global warming pollution by 90% in developed countries. That means in this country. He wants to cut our carbon dioxide emissions by 90%, and pretty soon. And meanwhile, he's playing a bait and switch game with these concerts. He has shills like Cameron Diaz telling people that what's involved is, well, she turns the shower off when she shaves her legs. That's her contribution to fighting global warming. And they're also advocating that we must sign this international treaty that will cut carbon dioxide emissions by 90%. So they're playing a game, I have to say, with a lot of drugged out people who can't comprehend what they're being told. Well, whether the per capita reduction in carbon dioxide emissions is to 6%, to 10%, as Gore would like, or 11.25%, whether or not a few percentage points of reduction can be avoided by virtue of obtaining additional power from other sources, the clear implication is economic devastation. It's devastation in the production and use of energy, and devastation in the production of everything that depends on energy, which is virtually everything, period. Such devastation and impoverishment is the actual goal of environmentalism, not rescuing the planet from global warming. If global warming were in fact a problem, the last thing that would be needed to solve it would be the willful destruction of the world's energy base. Energy use is the means by which modern man copes with the problems created by his environment. It is what enables him to accomplish with his meager muscular endowment the amazing productive results he does accomplish, and increasingly nowadays with little more physical effort than the pressing of buttons, the pulling of levers, or the turning of dials. To decimate his supply of energy as the means of better enabling him to cope with his environment makes about as much sense as amputating his right arm as the means of coping with his environment. At the risk of shocking anyone who may have been so influenced by environmentalist propaganda as to have lost the ability to see the obvious, one important use for energy that will become substantially greater if the world is to go through a period of warming is that required to provide air conditioning and refrigeration. More air conditioners will be needed, and the air conditioners will need to run more often. More refrigerators, more refrigerated trucks, ships, freight cars, and warehouses will be necessary. I know that the environmentalists and their dupes must hear such words as blasphemy. To the environmentalist way of thinking, coping with global warming requires the abandonment of air conditioning and refrigeration, or at least the far greater part of it, because they entail the discharge of carbon dioxide into the atmosphere. Well, this matter of the role of air conditioning and refrigeration in coping with global warming represents a much wider and more profound issue, namely the difference between the common sense perspective of the individual and the convoluted perspective of collectivism. From the perspective of an individual who wants to live and work in a pleasant temperature despite oppressive heat outdoors, and who wants to keep his food and beverages fresh, air conditioning and refrigeration are the obvious answer. However, environmentalism cares nothing for the perspective of the individual. Its perspective is that of the human race as a whole, and not only the totality of the members of the human race now living, but that of the totality of the human race extending into the indefinite future, i.e. that of children, grandchildren, and great-grandchildren as yet unborn, as well as the generations to follow them. It demands that the living sacrifice the comfort and healthfulness of air conditioning, refrigeration, automobiles, electrical appliances, everything and anything that depends on man-made power, for the alleged sake of people who will not be alive until the next 100 to 1,000 years. Indeed, according to the Stern Review, if governments do nothing to interfere, the projected rise in temperature by the end of this century, quote, may exceed 2 to 3 degrees centigrade, end quote. Now, this is certainly a rise that people could live with. It is only the next century in which, quote, 5 to 6 degrees centigrade warming is a real possibility, end quote, according to the Stern Review. Such an increase, too, if it actually came to pass, would be within mankind's means of coping. And note, incidentally, these temperature increases are increases above pre-industrial levels, not present or future levels. we've supposedly already had an increase of 0.5 degree centigrade. Beyond that, the Stern Review is content with asserting that, quote, there is some evidence of small but significant risks of temperature rises even above this range. Such temperature increases would take us into territory unknown to human experience and involve radical changes in the world around us, end quote. Thus, we are being asked to sacrifice modern industrial civilization on the basis of a projected warming above present temperatures on the order of 1.5 to 2.5 degrees centigrade this century, followed by, quote, a real possibility, end quote, of 4.5 to 5.5 degrees centigrade in the next century, coupled with, quote, some evidence of small but significant risks, end quote, in the still more remote future of further temperature increases. Industrial civilization is to be sacrificed in the name of a projected rise added to a real possibility, added to some small but significant risks. This may sound like a compelling case to the likes of Al Gore, but it certainly isn't for anyone capable of weighing the alternatives. In answer to such insanity, it must be stressed that even if global warming at the levels projected turned out to be a fact, which is far from certain, the free citizens of an industrial civilization, as I wrote in Capitalism, would have no great difficulty in coping with it. That is, of course, if their ability to use energy and to produce is not crippled by the environmental movement and by governmental controls otherwise inspired. The seeming difficulties of coping with global warming or any other large-scale change arise only when the problem is viewed from the perspective of government central planners. It would be too great a problem for government bureaucrats to handle, as is the production even of an adequate supply of wheat or nails, as the experience of the whole socialist world has so eloquently shown. But it would certainly not be too great a problem for tens and hundreds of millions of free-thinking individuals living under capitalism to solve. It would be solved by means of each individual being free to decide how best to cope with the particular aspects of global warming that affected him. Individuals would decide, on the basis of profit and loss calculations, what changes they needed to make in their businesses and their personal lives in order best to adjust to the situation. They would decide where it was now relatively more desirable to own land, locate farms and businesses, and live and work, and where it was relatively less desirable, and what new comparative advantages each location had for the production of which goods. Factories, stores, and houses all need replacement sooner or later. In the face of a change in the relative desirability of different locations, the pattern of replacement would be different. Perhaps some replacements would have to be made sooner than otherwise. To be sure, some land values would fall and others would rise. Whatever happened, individuals would respond in a way that minimized their losses and maximized their possible gains. The essential thing they would require is the freedom to serve their self-interests by buying land and moving their businesses to the areas rendered relatively more attractive, and the freedom to seek employment and buy or rent housing in those areas. Given this freedom, the totality of the problem would be overcome. This is because under capitalism, the actions of the individuals and the thinking and planning behind those actions are coordinated and harmonized by the price system. As a result, the problem would be solved in exactly the same way that tens and hundreds of millions of free individuals have solved much greater problems than global warming, such as redesigning the economic system to deal with the replacement of the horse by the automobile, the settlement of the American West, the release of the far greater part of the labor of the economic system from agriculture to industry. The most important principle to keep in mind here, as I wrote in Capitalism, is that whether global warming comes or not, it is certain that nature itself will sooner or later produce major changes in the climate. To deal with those changes, and virtually all other changes arising from whatever cause, man absolutely requires individual freedom, science, and technology. In a word, he requires the industrial civilization constituted by capitalism. This is the system that is required for living and coping with nature, not one in which governments conscript the entire population of the world into a collective mass compelled to achieve some global goal, whether the building of socialism or the reduction of carbon dioxide emissions. Collectivism, socialism, is a failed, dead economic system. Environmentalism and its hysteria over global warming is its intellectual death rattle. Thank you.